Okay, Assalamualaikum and good afternoon to all. Okay, so I will share the question in another 1 minute through the Google Classroom and also the WhatsApp group. Okay, so you have about 30 minutes to uh, answer your questions, and then you have about 10 minutes to submit through the Google Classroom if possible. If not, you can WhatsApp me personally lah your answer scheme. Okay, so you can use your own paper, and then I need the PDF version. I don't want the picture, okay, because it is not clear. Okay, so please on your camera for the quiz. Okay, so quiz already in Google Classroom. You can download from the Google Classroom. I will share through the WhatsApp the questions. Okay, so you must start now. We finish at 12:36 for the answering the questions, and then you start with the submission process. Good luck. Boleh je. Yes, because it is in Word. You can answer in that quiz and upload lah. Okay, you should start answering the question now. Okay, and start with the submission process. Okay, stop answering the question and then start with the submission process. Okay, so please upload in Google Classroom. If cannot, then you can WhatsApp me, PM me your answer scheme. Okay, make sure you click turn in after you upload so that trigger lah you already submit. Okay, so I wait for your submission until 12:45. Okay, 12:46. And then after that, I will consider late submission. Okay, 12:46, all the answer scheme must be in Google Classroom, or you can WhatsApp me if cannot, upload in Google Classroom. So after 12:46, I will consider late submission. Okay. After that, you can turn off your camera and then we start with the class.
Sorry, madam.
Yes.
How to add the PDF into Google Classroom?
I think you can find a button there to upload your file. Cannot? You don't find that one?
I don't found that one. How to upload?
Upload to Google Drive first, then send your Google Drive.
Oh, need
then
to upload to Google Drive first. Okay.
Madam, boleh tukar tu tak apa tu kalau tadi saya lupa nak section dekat angka shift. So boleh tukar balik ke file.
Pardon, apa?
Kalau dekat artikel tu tadi saya tak boleh section. So nak kena tukar ke file yang saya serahkan tadi.
Tukar file, saya tak dengar sangat lah cakap apa.
Untuk section saya dah tulis dekat kertas jawapan. So nak kena upload yang baru ke dia ada?
Nak tukar apa? Tukar jawapan ke apa?
Tak. Mana kertas tadi tu saya tak tulis section.
Kertas. Saya tak faham apa macam mana. You dah upload dah? Okay. You dah upload ke belum? Itulah, saya tak clear you tanya apa.
Guna chat.
Yang sheet tak ada section. Oh, that's okay because the Google Classroom only for your section. So, it's okay. There's no section in your answer scheme. Okay, that Google Classroom only for your section. Okay, so still 11. But a few already submit through the WhatsApp. 1, 2, 3, 4, 5. Another 6%. Okay, so I think let's start the class. Already take note who who still not yet submit the answer scheme. Okay. Okay, so let's start the class. And please do not submit to me the picture of your answer because it will be problem for me to mark later. Okay, it is not clear one when you submit the picture. Okay, please try as the best that you could to submit in PDF form. Okay, so we shall start the class. Okay. So as what on Monday already asked you to study from 1.3.4 until so I think we start with the 1.4. Okay, so we start with the 1.4, the EDA, Exploratory Data Analysis. So we are going to discuss how to identify the outlier and also how to draw the box plot and interpret the box plot. Okay, so I think all the calculation part is yours. Okay, you can always watch the video how many times that you want, okay, to make sure that you understand how to sketch the box plot. Okay, because box plot is easy, but how to interpret the box plot. So we are going to discuss how to interpret the box plot by using the exercise that I asked you to do. Okay. Okay, so exercise 1.4.2. Before that, next week supposed to be quiz 2, isn't it? The topic 2.2. Okay, based on your TP here. Can I know how many of you still don't have the statistical table and formula? This one? How many of you still didn't buy this one? Because quiz 2 we need to use this table, this statistical table for the quiz 2. Because as I mentioned before this, the only book that you can use during the quizzes, during the test and final only this one. Okay, because all the formula is in this table and also we use some of the critical value. Okay. So I think we So some of you still don't have this one. So, so we try to postpone quiz 2 on week 5 before the test. Okay, so we postpone the quiz 2 on week 5. Okay, we try to do before the test. Okay, so which is on week 5 lah. Okay, maybe I will inform later the what we call the date and so on, but it will be on week 5, not next week lah. Okay, so quiz 2 topic 2.2. Okay, test will be week 6 as I mentioned before this. Okay. Okay, so we go to the exercise 1.4.2. I will not touch how to draw the box plot. Okay, you can always watch the video on how to draw the box plot. What I want to highlight here is how we are going to interpret the box plot. Okay, that one is important lah. Interpretation is important. Calculation is much easier than that. Okay, so the question 1 here, you have 1A and 1B. Okay, so you have single data. It means that you have one set of data on each question. 1A and 1B means that you have only single box plot on that axis. Okay, so in general, your box plot consists of 5 number summary. Okay, so 5 number summary. You have the minimum value. Okay, you have the minimum value of your data set. You have the Q1. We already discussed how to calculate Q1. You have the median or the Q2. So it's up to you. You can use the formula of the median or you can use the formula of the Q2. Both will give you same value lah. Okay, but to be easy, we just use quanta lah. Okay, so the value of the Q1, the value of the Q2 or median. The fourth one is the value of Q3, and then the last one is a maximum value of your data set. Okay, so your box plot, it is about those 5 number summaries, and then we have to plot the outliers if exists in your data set. Okay, if there is an outlier in your data set, then you have to plot in your box plot. Okay, so other than that, we don't plot in our box plot. Okay, we don't plot the lower limit, the upper limit of the outlier. Okay, from the experience, some student tends to draw the upper limit and lower limit of the outlier. Faham Upper limit and lower limit of the outlier, it is a limit that we find in order to know whether our data consists of the outlier or not. Okay, so you have the lower limit and then you have the upper limit. If there is a data value exceed those 2 limits or maybe one of the limits, then it is outlier lah. So we have the outlier. Okay, so your box plot only based on those 5 number summary and also outlier if exists. If not, only those 5 value lah. Okay, so we go. So when we have single box plot on the axis, okay, I think we have, okay, the answer is here. Okay, so single box plot. So we have missing here. You need to label the box plot. Okay, so you have to notify here. This is the minimum value. This is the Q1, Q2, Q3, and also the maximum value. Okay, if we have the outlier like the question B here, this is the outlier, so you have to label here outlier. Okay, without the labeling, you might lose 1 mark. Okay, so when we have single box plot on the axis, okay, so here we have the horizontal box plot. You can always plot the vertical box plot. So vertical box plot, we use the y-axis as our axis. But here we have x-axis, so then you have the horizontal box plot. So what we can write here, what we can interpret here, you can write the shape of your box plot. Okay, when we have single box plot on on the axis, then the only thing that we write is a shape of our box plot. Okay, but still we can discuss the variability and also the average of our box plot. Okay, but it will be more meaningful when we compare the box plot. Okay, you can interrupt me if you have any questions. Okay, as usual. Okay. If you stay in Sabah, we try to figure out some solution for the Sabahan student. Okay, because we know that it will take a long time lah for the postage. Okay, so stay tuned. Okay, we go to the question 2 here. Okay, so we have 2 samples of the 10 spring made out of the steel rods supplied by 2 different companies were compared. So the measurement of the flexibility of each spring was recorded as follows. Okay, and compare the distribution by using box plot. So the keyword here we have this. So automatically it is compulsory to compare this distribution by using the box plot. Okay, so give comment. Okay, so compare using box plot means that you have to draw 2 box plot on the same axis. Okay, when we compare data set by using box plots, means that those box plot must be drawn on the same axis. Okay, so it doesn't matter you are using x axis or y axis, those 2 box plot must be on the same axis. It cannot be on separate axis. Okay, if separated, then it is not comparing. Okay. So after you plot, then give comment on the flexibility of the springs supplied by the 2 different companies. Okay, so the keyword here, flexibility. Okay, so we go to plotting. Okay, so this is the answer. Okay, you should have your own. Okay, and then we go to the interpretation. Okay, so label must be that. Okay, so when you have more than 1 box plot on the same axis, then you have to plot lah. Okay, this box plot for which data set and this box plot for which data set. Okay, so in this case we have the first one here, company A, and the second one here, company B. Okay, if not, reader cannot know lah which that box plot for which data set. And then label. Okay, so we have the outlier here. Okay, so when you have the outlier, it is compulsory to plot your outlier here parallel to each box plot, so that we know that this outlier belong to this box plot. Okay, you cannot plot the outlier which is not parallel to each box plot. Okay, if not, we read the outlier for another data set. Okay, so label your box plot. We have mean here, Q1, Q2, Q3, and we have max. Mean, Q1, Q2, Q3, and then we have max. Okay, so that's the what we call technical. Okay, so label your box plot. Okay, and then okay, back to the question. Compare the distribution. So first one that you have to write, distribution. Okay, so distribution here means that it is your shape of your box plot, the shape of your box plot. Okay, distribution, shape of the box plot. Why we have to construct the box plot? Because it stated here we have to compare by using box plot. So in order to know the distribution here, you have to sketch the box plot. Okay, so it is clear lah why you have to sketch or plot your box plot. Okay, and then we need to answer the question here. Okay, so first, distribution. Distribution is a shape of your box plot. Okay, Any questions so far? Any question? Any question? No?
No,
No,
madam.
madam.
Just need to know whether you are here or
No.
not. Okay, so distribution
No,
first.
madam.
Okay. Okay, distribution means that shape of your box plot. So, company A, and then we have company B. Oh, sorry, what is the variable of our data? Variable, what is the variable here? Anyone? What is the variable? Anyone? Variable? You can write on chat.
Measurement of flexibility.
Measurement of this flexibility. Okay, so flexibility of spring. Okay, so first distribution. Okay, so by using box plot, there is only 3 distribution that we can identify. Okay, first one, right skewed, left skewed, and also symmetric. So similar as a central tendency, measure of central tendency. Only these 3 distribution that we can know based on measure of central tendency and also box plot. So whether it is a left skewed, right skewed, or symmetric. So in this case, company A. So how do we identify based on Q2 here? Okay, so in this case, based on the box here, Q2 here close to the Q3, then it is a left skewed. It is a left skewed. Okay, and then for the company B, your Q2 close to the Q1, then it is a right skewed. Okay, so how it is a symmetry? Okay, if symmetry, let's say that we have this, sorry. Okay, let's say that we have this box plot and your Q2, the middle. Okay, when we have Q2 at the middle of the Q1 and Q3, then we have to consider the line here. The line that connect the box to the minimum and maximum. If we have similar length, then it is a symmetry. Okay, then it is a symmetry. Okay, but when we have Q2 close to the Q3 or Q2 close to the Q1, then you can right away know that it is a whether left skew or left skew. Okay, so in this case, A is a left, B is a right. So left skewed and then right skewed. Okay, so done with the distribution. Okay. Okay, then we have to comment on the flexibility of the spring. So how to comment on the flexibility of the spring? What value that we can use? Okay. Okay, so flexibility of the spring, it is a quite general question. So similar as before, there is a 2 value that we use to compare our data. One is based on average, and number 2 is based on
Variance.
probability. Yes, variance. Oh, look at that. Mhm. Okay, so flexibility of the spring, you can comment on the average or durability. So similar as before lah. There is two value that we use, okay, that commonly used to compare the data set. First is average and second one is a probability. Okay, but for the box plot is what we call is one of the graph. So when it is graph, it is based on the visualization, how we see that data, okay, how we comment on that data. So it is not really accurate one, okay. So that's why for the average and probability here, for the box plot, for the average here, we always use median, not the mean. And for the probability here, we always use the IQR. Okay, if you go through the note, okay, we have statement that if your data is skewed, then we use median and IQR. If your data is symmetric, we use mean and variance. But for the case of box plot, even though we get symmetric, it is not really confirmed it is symmetric because box plot is based on visualization, how we see based on our eyes visualization. So it is not really accurate. So for the case box plot, okay, when we need to compare the average, it always be median value. Okay, median value, and when we compare durability, we use the IQR. Any question? So far, we don't use mean and also the variance. Okay. So, okay, so what we do here for the average. Okay, so median is a Q2 value. So Q2 of the A, we have 8.25. Q2 of the B, we have 10.15. Okay. Okay, so compare first. So you can start with the A or you can start with the B. So Q2 of the A less than Q2 of the B. Okay, so the average of A less than the average of B. Okay, because for the average here we use the Q2. So so which one is more flexible? For your opinion? Median of A, or okay, it is an average now. Okay, even though we use the median, it is an average. Okay, we talk about the average. So average of A less than average of the flexibility of A less than average of the flexibility of the company B. So which one is the best one? Which one is more flexible?
B.
It is B. So you can write here. Okay, stream B is more flexible. Okay, stream B is more flexible. One of the interpretation that you can write based on the average. Another one that you can write based on the average, I will insert here. Okay. Okay, you can compare and you can discuss which one is more flexible, or you can just discuss the average. Okay. Because here, in this question, the question is comment on the flexibility. It is not like identify which one is more flexible. So it's up to you. You can talk about which one is more flexible, or you can just compare the flexibility of the spring based on the average. Okay, it's up to you. It is not like previous one we have which one is more better, which one is less consistent, for example. Okay. Okay, another way to interpret your average. Okay, so average. Okay. Okay, so Q2, median is a middle of your data set. So you can write that the flexibility of okay, so Q2 value, the unit here is NM. Okay, so you can write here the flexibility of 50% of the spring A, because median is a middle of your data set. Okay, is more than 8.25 nm. Okay, if you write like this, is it correct or not? If you write the flexibility of the 50% of the spring A is less than 8.25, is it right or not? Is it correct or not? If you write less than. Anyone?
Not sure.
Not sure. Other than that? No. Again? Okay, so now median is a middle of your data set. This is your median. Okay, we have 50% here. We have 50% here. Okay, so I repeat my question. Is it correct if we write less than? So here is an 825. Is it correct or not?
Yes.
Yes lah. It should be yes. So now when we have median is a middle of your data set, 50% above 8.25 and another 50% below than 8.25. So it's up to you. You can write more than or you can write less than. Both will be accepted because both are correct. Okay? Yeah? Okay. So similar to the spring B. Or 10.15. Okay, so so at least you have two ways, okay, to interpret your average when we have the box plot. Okay, you can compare your average and then you can notify which one is a better one. Okay, or you can just interpret, okay, your data based on the average value. Okay, it's up to you because the question here just to comment. Okay, just to comment, not to identify, not necessary to identify which one is more flexible. Okay, and then we go to the verbability, how we comment on the verbability. Okay, so verbability is based on the IQR. Okay, so you can comment on the verbability of your data set. So find first the value of the IQR for the A and the value of the IQR for the B. Okay, so A 1.5, B 1.2, isn't it? 1.2. Okay, so you can compare. So IQR A greater than IQR B. Then which one is more flexible? Based on the verbability here, it is. So A is more, IQR A is more than IQR B. So which one is more flexible? It is?
B.
It should be spring A or spring B?
Okay.
Okay, remember what we have discussed last week about the verbability. Okay, if we need a good data, the probability should be how? Should be what? We need smaller or higher? If we need a good data.
Smaller.
Smaller probability.
Probability. So here, which one is more flexible?
B.
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 Should be B. Should be B because the IQR of B less than IQR of A. Because here is a probability. Just now it is an average. Okay. So spring spring B is more flexible. Okay, so means that here doesn't matter you use probability or use the average, you have to come up with the same. If you try to identify which one is the best one, it doesn't matter you use average or probability, you have to come up with the same answer. Okay, takkan contradict punya. You takkan dapat here spring A and another one spring B. Tak boleh. Okay, it must be something wrong somewhere. Whether you compare the mean or whether when you use the variability here. Okay, doesn't matter what value that we use, the answer must be similar. Okay, and here you okay. If we go back to the measure of position, okay, IQR here it is about 50% of your data. So you can talk about that lah. Okay, so Q. Okay. Other than you compare, you can talk about this 50% of your data. Okay, so I show for the company A. company A. So the Q1 is 7.3 and the Q3 is 8.8. Okay, then you can write okay, so by usability you can write this comment lah. But usually when we use usability, we go to the comparing. Okay, comparing the data set and then we try to identify which one is more consistent or which one is more accurate. Okay, any question on how we comment on the box plot?
No, madam.
Okay, so calculation is easy. Okay, I believe that most of you already discussed box plot before you come to this subject, maybe during their secondary school or form 6 or matriculation. But the more important part is the interpretation, how we are going to interpret the box plot. Okay, plotting is easy. Okay, so you can always watch the video on how to plot your box plot. Okay. So similar to 1.5 here, okay. So this is a simple one. You just watch your video. So normal probability plot here, it is in part 2 of your assignment, okay. Because okay, so normal probability plot is easiest way, okay, to check whether the data that we have here is a normal or not, okay. Because this course, the applied statistic course here, all the method that we discuss in this course, it is for the normal data actually. Okay, it is for the normal data. Okay, so because in your part 2 of your assignment, it is about hypothesis testing. So hypothesis testing that we discuss in this course, it is for the normal data. So that's why we need you to check on the normal first, whether your data is a normal or not. If not, then we just assume that it is normal for the study purpose. Okay, if you have a real data, if your data is not normal, you have to use another method for the hypothesis testing. Still hypothesis testing, but we call it as a non-parametric method. Okay, what we discuss in this course, parametric method. Okay, or you can normalize first your data lah. But for your assignment purpose, you just check whether it is normal or not, and then you just comment there whether your data is normal or not, and then you just proceed to the hypothesis testing as the data is a normal. Okay, we just assume that the data is a normal. Okay, so you just watch the video how to construct this one. Okay, so and then how we comment. Okay. Okay, this is the easiest way. We use what we call plotting, visualization, how to know whether the data is normal or not. Okay, if your sample point here, okay, lies in a straight line, then your data is a approximately normal distribution. Okay, we cannot write it is normal distribution because normal distribution, your data must be 0 for the mean and 1 for the sigma. Okay, 0 for the mu and 1 for the sigma square. Then it is 100% normal. That's why here we say approximately normal distribution. Okay, if your data lies on a straight line, then we can say approximately normal distribution. Okay, if deviate from the straight line, then your data is not normal. Okay. So other than that, okay, this one just visualization to confirm that, when then you can use a test. Okay, we can go to the task to confirm whether it is a normal or not. So we have a few one here: Kolmogorov, Anderson, Darling, and Shafirovic task, the commonly used. Okay, based on this task, then we can confirm whether it is a really normal or not. Okay, so you can try this exercise in your Microsoft Excel, then you can see whether the data is a normal or not. Any question for the normal probability plot? Okay, so that's all chapter 1. Okay, that's all chapter 1. Okay, we go to the chapter 2. Are you still okay to continue the class?
Ya, ada.
Have you done the exercise here? Exercise 2.1 here, then the number 2. Done, eh? Okay. Okay, so actually when we start with the chapter 2, you need to have this statistical table lah, because we discuss how to find the critical value in this table, okay, and also the formula that we have, okay, but you can always watch the video after this, okay. Okay, so chapter 2, it is about confidence interval. There is no more sampling distribution here. Okay, there is no more sampling distribution. Okay, if in our module we still have sampling distribution, but in our syllabus we already take out that one. So only confidence interval. Okay, so confidence interval is inferential statistic lah. Okay, one of the method for the inferential statistic. Okay, so we have 7 subtopic. Okay, so the 2.1 is just a theory behind. Okay, I guess that you already watched the video, that video made by me. So if I discuss here, I will just repeat what I already said in that video. Okay, I think this quite complete information that you have to know lah. Okay, so I'm not going to go through the theory today. Okay, I think we just go to the 2.2. Okay, but you have to know that why we construct the confidence interval. Okay, it is to estimate. Okay, estimate the value of population. Okay, so what we have here, we find the interval. So we have A, we have B, the confidence interval. Okay, so what we are doing here, we find the value of A and we find the value of B here. Then we assume that our population value lies within this interval, somewhere in this interval, and we don't know which one. Because when we talk about the true value, it will be quite, not impossible, it is possible, but quite difficult to get the true value. Okay, the true value of mean, the true value of variance, and the true value of the proportion. Okay, so what we have here, we just estimate the estimation of the population value. Okay, so we are using estimator value. Estimator is a statistic value or sample value that we calculate from sample data. So we are using estimator value. to find the A and B here in order to estimate the population value. Okay, so should get it lah, the what we call the terms that I used just now. So the confidence interval value, the process to find the interval, that is estimation process. Okay. So I think we go to the 2.2. Okay. You can always watch that video for the theory. I think I have talked a lot in that video about the theory behind why we calculate the confidence interval, what you should know about the confidence interval, okay, how confidence interval, so that we will have a good confidence interval. Okay, so we have three common values that we use here. The first one, population mean, and then we have population variance and or standard deviation, and then we have the proportion. Those are three common values that we calculate when we have a data. Okay, so the first confidence interval, it is for the population mean. So what we have here, we find A and B, and then we assume that our population mean lies within that range. Okay, that's why we have population mean here. Okay, or we call it as a true value ataupun hypothesized value. Okay, I have mentioned before this, so just a revision. Okay, sometimes we use true value, sometimes we use hypothesized value, but you should know that it is a population value. Okay, so to estimate the confidence interval for the population mean, when population variance or standard deviation is known or unknown. Okay, and then to estimate the sample size by using the concept of confidence interval for the population mean. Okay. We go to the formula. Okay. If you have this statistical table, okay, this is the new version, the latest one, or you can always use the old version. This is the first version. Okay, and then we have the orange one for the second version. Okay, and this is one, the latest one. Okay, can you see? Boleh nampak tak? Can you see, class?
Nampak?
Okay, I see here,
Yeah.
right?
Yes, madam.
After this, we go to the lunch.
Yes, madam.
Okay. Okay. So go to the page. If you have this module, then you can refer to your statistical table, to your book. Okay. The page 5. Okay, starting from page 5 until page 9, it is a formulas that we use from chapter 2 until chapter 6. Okay, only formula from chapter 1 is not in this table. Chapter 1 you have to memorize, but we just have a few formula. Okay, so confidence interval, it combines with the hypothesis testing. Okay, page 5. The first column, it is for the confidence interval, and the second column, it is for the hypothesis testing formula. Okay, if you try to find the confidence interval for the confidence interval, then refer to the first column, the chapter 3 letter, second column here. Okay, but the formula in your statistical table, it is not complete as your module, as the note that we have here. Okay, so in this statistical table, okay, for example, in this slide, you have the formula when sigma is known and sigma is unknown. I will discuss after this what does it mean. And for the n greater than 30, okay, and n less than 30. But in this statistical table, it didn't mention which one for the known, which one for the unknown, which one for the n greater than 30, which one for the n less than 30. You have to know by your own, that one. Okay, that one you have to memorize that one. Okay, we have keyword to know. Okay, this formula belong to known or unknown. This formula belong to n greater than 30 or n less than 30. Okay, so that's why whenever you do your exercise and tutorial, practice to use this statistical table. Okay, because when we go to the quizzes, when we go to the tasks, when we go to the final, this is the only one that you have. Okay, the only book that you can refer. Okay, so that's why you have to practice how to use formula in your statistical table. Okay, do not always refer to the module because module is a complete one. Okay, if not, you will get panic later on. Okay, why I say like this, I just assume that when we do the quizzes, tasks and final, it is like face-to-face in class lah. I don't want another side. I don't want to know another side that you do lah. Okay, so like face-to-face in class, so we just regard it as a face-to-face in class. So this is the only one that you have during the assessment. So that's why you have to practice how to use it. Okay, clear? Okay. Okay. So confidence interval for the population mean. Okay. It will be mentioned in that question. Okay. You need to construct the confidence interval. For example, construct the 90% of the confidence interval. It will be mentioned in your question. So you should know right away that we have to construct the confidence interval. Okay. For the population mean, so here is a clear lah. Okay, that you have to construct the confidence interval for the population mean, or we use another term. Maybe for the average also similar lah, population mean. Okay. So we have three formula that we need to consider for the population mean. Okay, the first condition that you have to know is a sigma is known or sigma is unknown. Okay, sigma is known means that we have sigma or sigma square in our question. Sigma is unknown means that you have S or S square in your question. There is no sigma. Then we have sigma is unknown. That's the first condition that you have to identify in your question. That's why I said in previous class, sample population, it is very important when we go to the chapter 2 onward, okay, especially chapter 2 and 3, because this one, okay, you have to know the variance given, it is a population or sample variance, okay, because it will be influence the formula that we are going to use. Okay, so if you have sigma in your question or sigma square in your question, then we use the first formula here. Okay, and here we have Z distribution for our distribution. Okay, so the keyword that we have, how do we know this formula for the known? Because you have sigma. Okay, so in your table here, statistical table, formula with the sigma here, it is for the known. That's how we know lah. Okay, and then if unknown means we have S or S square in our question. Okay, we need to identify the second condition. This is second condition. Whether we have larger n, whether we have small n greater than equal to the 30 or n less than 30. When greater than 30, then we use the Z with the S, the keyword. Okay, so in your statistical table here, you have S and Z, it is for the unknown. Unknown sebabnya S kat sini bukan sigma. And then Z for the larger sample, n greater than 30. That's how we know. Okay. For the n less than 30, so similar we have s because of unknown, we don't have the sigma value. And then but for the small sample size, we have t distribution here. Okay, we have t distribution. That's how we know this formula for the unknown and n less than 30. Okay. We go to the distribution, z and t. Okay. So z distribution and t distribution. Okay, how to find this value? By using the statistical table. We call them as a critical value. Okay, for the z distribution, it is, okay, in our formula, it is alpha divided by 2. Alpha divided by 2. So that's a probability value. Okay, alpha divided by 2. So how we know what is our alpha? Based on confidence level. Okay, if you already watched the video, then you should know lah. Okay, what is confidence level? What is alpha? Alpha is a significant level. Okay, for example, that we have to construct 95% of CI. CI is a confidence interval. So 95% it is a confidence level. So one minus alpha, it is equal to the confidence level 0.95. Okay, it is a probability value. Okay, so 0.95, then your alpha is 0.05. Okay, that's how we know what is our alpha, based on the confidence level in probability, because alpha here is a probability. Similar to the confidence level, it is a probability. Okay. Okay. So z alpha over 2. So alpha here we need to divide by 2. Then we get 0.025. So we need z 0.025. Okay. Find your statistical table here. Okay. It is in page. Okay. If you have your own now, then you can refer. In page 36. Okay, different version you might have one different or two different of pages. Okay, so page 36 here, table 4. Okay, doesn't matter what version that you have. For the Z distribution, it's always on table 4 because Z is a normal distribution. So that's why we have normal distribution. Okay, so table 4 here, we have alternate column. First column alpha and then the answer, and then repeat with the alpha and the answer. So find 0.025 in column alpha. Okay, because alpha here it is our alpha over 2 lah. Okay, based on here. Okay, so find 0.025 in this column. Yeah, in the column of alpha. So you have on second column of alpha, which is third from here, 0.025, we have 1.96. Get it? For those who already have this table. Dapat tak? Jumpa tak? For those already have this one, this statistical table. Okay. And then for the T distribution, okay, so T distribution, we have two value come with the T. First is a probability value and second one is a degree of freedom. So here is a alpha over 2 and here is a null. Okay, based on your formula here, we have alpha over 2 and then nu. Package for the t distribution. So nu is a n minus 1, sample size minus 1. So we use similar confidence level, alpha 0.05 divided by 2, then we have 0.025. So nu here, for example, that we have here n equal to 10. So 10 minus 1, 9. So 9. So it is a package, okay, for the t. It is not separate because when we need to find the t, we need the probability value and also degree of freedom. Okay, so the page after that, the page after the z, okay, which is table 5, percentage of the t distribution. Okay, so the first column here you have for the nu. Nu is a degree of freedom. Okay, this one. Okay, and the first row it is a probability value for the first one and for this one. Okay, so find the combination of the 0.025 with the 9. Okay, probability value 0.025 and 9. What is the value? Someone? Anyone? Two point 2622. Okay, so 2.2622. Okay, for those who still don't have this one, then when you get yours, then practice on how to find this value. Any questions so far? Okay, I think we stop here. Okay, so siapa yang tak buat lagi exercise, we can do it after this. Okay, because it is already 1:51. Okay, so we stop here. Okay, next week we continue with this exercise first, 2.1, before we continue to the rest. Continue to the subtopic for next week. Okay, so again next week, quiz 2 will be on week 5. Okay, it is not next week lah, so we can bring this one to next week. So as usual, our class will be on Wednesday. If I need a class on Monday, I will inform early lah. Okay, any question for today? Any question?
No.
Okay, so I will upload this video in YouTube as usual, then you can watch lah if you want. Okay, so that's all for today. Thank you for your cooperation. Thank you, class. See you next week, insyaAllah.
Thank you, madam.
Okay.
Thank you, madam.
Okay.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, Doctor.
Okay.